Hi, and welcome again to the eLearn program brought to you by the Division of Education, Innovation and Energy. My name is Mr. Thomas, and I will be teaching you organic chemistry. So, the question here is asked, name the following alkene. So, we just going to start off with a little complex one and we get down to the easier ones. All right, so what have we learned? When we are naming, so we sit looking at, sir, what is this, boy? This is a crazy structure. But let us apply what we would have learned. What we have learned, okay? So the first thing we know when we are applying to this problem is that one, we need to find out the correct ending for the name because we need to name this compound. And when we would see here, this is a double bond. And there being a double bond, which means that we are dealing with an alkene. So we know that the end of this compound is going to be in -ene. So all you just have to do is take your time. When you see some complex problems before you, don't take everything in at the same time. Take things one step at a time, and eventually you're going to solve the entire problem. All right? You can't take everything in one time. No one can do that. No man is an island. So you take things one step at a time, and I'm sure that you're going to make it. Remember your concepts, and that's what's going to help you to be able to answer your questions well. All right? So we know that's an alkene, and it being an alkene, we're going to add -ene at the end. Following there, we need to determine the longest chain with the double bond. So we need to include the double bond because we said that the double bond, when we are numbering the longest chain, the double bond must have the lowest possible number. So we found it here. How did I know this is the longest chain? Let me number it. So we said we begin 1, 2. So we could have done several ways. We could have gone like this. 1, 2, 3, 4. So that's just 4. I don't think that's enough there for me. Let's check our next one because I'm sure that there's more. Let's go. 1, 2, 3, 4, 5. So there's 5. Nice. So that seems more than 4. Okay. So let's try again. So this is how you do. You need to check your compound. If I went this way again, 1, 2, 3, 4, 5, it's same as the last we have. So let's check the next area and see what we get from there. So we have now 1, 2, 3, 4, 5, 6. So definitely that's the longest chain I can have. So I found the longest chain. That's why we would have isolated at this being this. So that's the longest chain. Finding the longest chain, we need to assign numbers to each carbon. And of course, we are now going to number the carbons. So we're going to number the carbon that is on the lowest number. We need to make sure that the double bond has the lowest number. So we begin by labeling with number 1. So we go 1, 2, 3, right down to 6. So we know that we have the longest chain, and now we can name this longest chain because that's the next step. So add a prefix. What's the prefix for 6? The prefix for 6 is hex. That is correct. Hex is correct. So, and what number carbon is the double bond on? It is on the first carbon. Remember, when we are numbering the double bonds, we ensure that the double bond has the lowest number. So the lowest number, the carbon with the lowest number is actually 1 that is connected to that double bond. Following ahead, we need to determine the side chains. What are the side chains? We have to look at them. So we look at this one. This is an ethyl. Why do we say it's an ethyl? Because of this entire chain, because this is the entire part that is out, we have how many carbons? 1, 2 carbons, and 2 is eth. All right? So this is an ethyl branch. Next, we have methyl, and we have another methyl. we have 2 methyls. All right? Now, we have to attach the names or branches in alphabetical order. So that's another step. Now, CXC is not going to give you, well, not going to give you a complex problem like this. I hope not. All right? All right? But even if they do, you know exactly what to do. All right? So 1, we name them in alphabetical order. E, of course, is before M, so we're going to put ethyl before methyl. So, and what carbons are the methyl and the ethylon? Well, I'll tucking back there. When we naming the branches, we also have to number them. The ethyl is found on the 2nd carbon, and these methyls are both fall on the 4th carbon. So we have 4,4-methyl. But that can't be it, because we said, so there's a rule that says that if we have any branches that are the same, we use the prefix di, tri, tetra. And since there are 2 methyl groups, we would group them together to call them dimethyl. And of course, we're going to keep the numbers 4, 4, and I would have explained the reasoning for that. So, our compound's name is 2-methyl dash. Always remember that you separate your numbers, your letters by hyphens, and your numbers by commas. Okay? So we have 2-ethyl or 2-ethyl dash 4,4-dimethyl 1-hexene. So that is the name of a compound. Or we can call it 2-ethyl 4,4-dimethyl hex 1-ene. Whichever one you choose is going to be correct. All right, so let's look at some simpler problems. All right, the simple stuff, the things that CXC is going to be bringing for you. And guess what? You're ready for it. All right, so let's tackle one of these questions. Look at this. All right, name the following alkenes. So let's look at this first one. How do we name? Hearing you all already. So, find the longest chain. And the longest chain must have the double bond. All right, so let's go. And of course, you're saying again, what? Number them with the double bond having the least number. So I'm going to start with the carbon closest to the double bond. So look, we have one here. So I have 1, 2, 3, 4, 5. So I found the longest chain. Nice. Look at right here. So the longest chain having 5. 1, 2, 3, 4, and 5. So I need to name the longest chain. 5 is pent, so I call it pentene. And what number is the double bond on? It is on the 2nd carbon. Okay? So we're continuing now from there. So we have some branches. What are our branches? They both consist of 1 carbon. All right? So they're consisting of 1 carbon. We know that is going to be methyl. So this is a methyl, and this next one here is a methyl. Are they the same? Yes, sir. So we need to say dimethyl. And in addition to that, we need to number them. The first one is on 2, and the next one is on 4. So 2,4-dimethyl. All right, so we're going to put everything together, and it's going to be 2,4-dimethyl 2-pentene. And we're done there. That's it. All right, so we named this one, and this one was very, very, very easy. I assure you. All right, I assure you, saying, sir, bring something more challenging than that, nah? All right, okay. I'm going to try and see if I could bring something more challenging. All right, so let me just give you a chance to take a little photo. If you can, if your TV could pause, you could pause it. You could rewind, depending on what station you're going to be using or what provider you have. I'll give you some time to take it in. All right? All right, so I'm going to erase now. So make sure you're taking notes, Very important. Let's look at our next one. Right. I'm saying, sir, yes, man. That's what I'm talking about. Okay. So what is our first step? As we said, we find the longest chain. We ensure that the longest chain has a double bond in it. We ensure that the double bond have the smallest number, smallest possible number. All right? And we're going to start. So I'm going to start here because I know that that's going to tell me that that double bond is only going to have a number 1. It's going to be common on the first carbon. So I'm going to start here. So let me just check. Let's check. 1, 2, 3, 4, 5. So we have 5. If I had gone this way, right? 1, 2, 3, 4. Now 5 is the longest. All right? So 5 is the longest. It doesn't matter which direction I would have gone. I could have gone at that one at the end. So let's take. So we found out the longest branch. So we have 2, 3, 4, and 5. So we number all our carbons. So we know that our longest chain is again 5 carbons, and we call it pentene. But what number is the double bond on? It's on the first one. All right. So let's move ahead. So we have some branches. So I have one branch here. 1 carbon is in this branch, so we call it methyl. Then we have our next branch here. That is also a methyl branch. Wow, nice. Moving ahead nicely. And there's another branch here. And this branch has how many carbons? 2 carbons. If it has 2 carbons, we call it ethyl. So we call it ethyl. What do we need to do? We need to put them in alphabetical order. Since we have 2 different branches, we need to put them in alphabetical order. All right, so what is the alphabetical order? The first one is eth. And what number? Because every time we name them, we have to say the number of carbons they are on. So ethyl is on the 3rd carbon, so it's 3-ethyl. Let's look at the methyls now. So we have 2 methyls, and because we have 2 methyls, we know that we have to say what? We have to call them now dimethyl. Okay? So dimethyl. So we know that it's going to be followed by, and what are the numbers on our dimethyl? We have 1 on 2, and we have the next one on 4. So it's going to be 2, 4 dash dimethyl. And what's in the last name we're going to put in? We're going to add that in one time. Dash 1 pentene. All right. And that's it. Look at this complex one. And we did it together. All right? And I know that you can tackle this on your own as well. So I'm going to give you some time to soak it in. Take your pictures. Take a snapshot, whatever device you are watching on, so that you make sure that you have this information down. All right? So I'm going to erase. No, get up ahead, because that's the last example here. Let's look at the practice again. So let's look at another one. Draw the following alkene. Draw the following alkene. Okay? So we're going to do a reverse now. All right? We're going to reverse this process. So we have to draw this one. What am I going to do? So you know exactly how to name a compound. So if they give you the name, you should be able to draw it. All right? So let's look at it. So the first thing we do when we drawing, we look at the last name. So I know that this compound is an alkene, even though we say that we are drawing the following alkenes. All right? Now we have pentene. So pentene is the longest chain. And we know this one here represents the double bond, the number that the double bond has on it. All right? So since it's pentene, we are going to draw out 5 carbons, long chain. So we're just going to keep it very simple. Keep this your long chains as their long chain. You're going to keep it like a straight chain. So we have 5 carbons. Now we need to know where to put the double bond. The double bond is on the first carbon. So I can make it here, or I could have put it over here. It doesn't really matter. All right? Because our numbering goes. So I'm going to keep it on this side. just because I prefer to keep it on that side. All right, no special reason. All right, next, we would have learned that we have an ethyl, which is the branch. So we know this here being the branch, and the number in front of the ethyl is the carbon that it is on. So we know that when we are numbering our carbons, that our double bond carries the lowest preference. So the second carbon would be right next to the carbon that would have followed that double bond. So we know that this ethyl is on that carbon. So I can erase here now, and I can put my ethyl with confidence. So I can draw it up, I can put it in condensed form, and I'm going to put it in a normal form that everyone could be able to follow as well. All right, we're going to do some more condensed later on. All right, so this is my ethyl group here. So because it has 2 carbons there. Now you ensure that your carbon has 4 bonds. All of them in my ethyl group have 4 bonds, and even the carbon that is bound to have 4 bonds. You can count it and you can ensure that as well. So next we have all our other groups coming in. H, and then you just close it off by adding in all your hydrogens. And that's it. So you have drawn here right now 2-ethyl pentene. Okay, so this is our example here. All right, so let's do our next one. So the next one we're going to look at is 2,3-dimethyl butene. All right, so let's erase here. So we apply the same concept again. All right, butene. So I'm moving a little faster now. Butene is the longest chain, so I know that I have 4 carbons in the chain. 1, 2, 3, 4. 1 tells me where the double bond is on. So I'm going to check it, I'm going to switch it up, I'm going to put it on the next side. All right, so it's under carbon number 1. So I know this is carbon number 1 here. All right, then I have branches, and my branches are dimethyl. So I know di means that I have 2 methyl branches. So that's what this di stands for, 2 methyl. So what we would have learned. And the number tells me what carbons they are on. So I know that my carbons go 1, 2, 3, and 4. All right? So it means, therefore, that there's a methyl group here. And there's a methyl group on the third one as well. So I can put it down, I can put it up, whatever one is necessary, doesn't really matter. So I would have established those that being the parameters for this particular example. And following, I would have now added in my rest of bonds, ensuring that all carbons are facilitating 4 bonds, ensuring that all your hydrogens are drawn out. Okay? And this is your compound right here. Let's look at the next example. So we have C. So it looks a little bit long. Let's see how well we can do this. All right? So let's look again. Let's try again. Applying all the concepts that we would have learned again. Okay? So, first step, longest chain. Longest chain is pentene. So I know that I'm 5 carbons long. 1, 2, 3, 4, 5. Where's the double bond located? 2, which is the second carbon. So I'm now 1, 2, so the double bond is right here. Okay? So the double bond is on the second carbon. Next, we have dimethyl. So we have 2 methyl groups, and we have the numbers where they are located, which is 3 and 4. This is carbon 3, and this is carbon 4. So I have a methyl group here, and I have a methyl group right here. So I'm going to put it on the same side. sometimes we alternate them to just make sure that we don't jumble up these information. So you see like what was going on here? So anytime you're drawing, you try to put them on the opposite side for drawing's sake, all right, so that you don't jumble them up. All right, so we are finished with that. Then we have a ethyl group, and the ethyl is on the second carbon. So the ethyl being on the second carbon, I'm going to put it down because I don't want to jumble them up. So I'm just going to erase these numbers here at the bottom to make space. And we are going to draw my ethyl. Ethyl is 2 carbons long, and we have that branch set in. And of course, that would be an error if I had drawn that. Let me just erase that bond. Okay. Why would that be an error? Because I would have ended up having 5 carbon facilitating 5 bonds. So next, just to continue my compound by putting all the hydrogens in the designated areas, ensuring that my carbons have 4 bonds. So I would count all of them: 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And I would observe that all my carbons have 4 bonds being facilitated on each. And this is the compound. So it was complex, it seemed complex, but you realize how easy it is now because of the knowledge that you have gained. All right, so let's go ahead. So let's look at this one here. This coming to the closing here now. Oh, sorry. So it says, write the following alkenes in condensed structural formula. So you have to make sure we have it in condensed formula. So there's a way in which you could draw them. All right. Some students draw it out in the normal way that they are accustomed for and then convert it to a structural formula. If that works for you, it works well. If it doesn't, there's another way in which you can do it. Okay. So it's simple. All right. Propene, which means that you have 3 carbons. All right. So propene, as we know that we put the numbers for where the double bond is located when we're dealing with 4 and up. All right. So propene, it's easy, right? So 1, I would have drawn this compound like this: CH2, because of the knowledge that I have, because this carbon is double bonded to another carbon. Because the first carbon, and as we know, because as you would have drawn this, if you would have drawn it initially, you would have done this. Let me just draw it out. All right, so you would have done 3 carbons in length. You would have put a double bond on one of them, and then after you would have put in your hydrogens. All right. All right, so for me, I would have said CH2 because I know this end would have had CH2, and the next one would have been CH because I know it's carbon double bonded, where we'll go to a hydrogen, which is 1, and then it needs to be bonded to a carbon that contains 3. All right, so that's what I would have done. All right, you would have seen the example, and the example would have done it like this. So this is your condensed formula for this particular one. Some students don't like condensed formula. I like condensed formulas because it makes you draw the compound at a faster rate. It's faster. All right. In addition to that, it saves you time if it's faster, especially if you're doing an exam and the exam have so much time. You need to try to find ways in which you can save time in your exam. All right? All right, so next. All right, so we have butene, and it's the same concept again. So this case is 2-butene. So why? Because 2 would tell me where the double bond is on, and it's on the second carbon, 1, 2. All right, so 2-butene, and I would have drawn it out this same way. So as I said, if it's easier for you to draw the structure first, and then go to the condensed formula until you get your practice in, you do so, all right? Just to ensure that you have it correct, okay? Afterwards, when you get the hang of things, you can easily be able to just draw it off of your head. And I'm going to give you an example. So, example, drawing the condensed formula of this one here. Because of practice over time, I was able to get this. So I know pentene, and it's 2-pentene. I know one end is going to have CH3 connected to CH. All right, because it's pentene. All right, I'm going to make some changes as I go. So 2-pentene. So I know my double bond is here. So I'm watching at everything one time. So I put a carbon, and when I put my carbon, I look. So there's a 2 here which says there's a methyl group. So there's a methyl group coming up here. So I would put CH3. All right. And then I would put my double bond because that's where the pentene is on. And I put my next C, all right, which is carbon 3, which is going to be CH, all right, which is going to be bonded to another carbon, which would have been carbon 4, which has another methyl group on it, CH3, which has an H on it because it's 4 of them, and then it's going to be 1, 2, 3, 4, CH3. So this is how I would have drawn it, all right? And I just check it back and I verify, and I did this from mine. This is what practice. This is what you're just applying all your concepts, and you would have seen it to be there. So you see, this and this is the same. No carbons on it, no carbons. The end is a CH3. The end here is a CH3. There's a CH3 above here. There's a C with an H on it, all right? There's also a C with an H on it here, right there. And there's a CH3 above, just like mine's. And at the end, there's a CH3. So I said it's the same compound, and this even shows you even more as we were talking earlier about drawing structural isomerism. Sometimes you could draw them the flipper way around, and they're actually the same compound, all right? And that's important, okay? All right, so let's move ahead. So the question here is name the following alkenes. So we need to name these alkenes. All right? So let's name them. So exciting stuff. So first thing we need to find the double bond, the one with the lowest number, and we find the longest chain. So the longest chain, let's try. 1, 2, 3, 4, 5. Okay, so that's 5. If I had gone this way, I would have gone 1, 2, 3, 4. All right, and I don't want that. That's a lower number. I don't want that one. So this is my longest chain. So if it's be my longest chain, I am now going to call this one 1, 2, 3, 4, 5. It's going to be pentene, but it's going to be 1-pentene. So it's going to be 1-pentene. All right. 1-. That's my longest chain. And then you have your branches. You have a methyl here and a methyl. That's dimethyl. And they're all on which carbon? 1, 2, 3. The third carbon. So it's going to be 3, 3. And since the methyl groups are the same, it's going to be dimethyl. All right? So I tell you this name is going to be 3, 3 dimethyl 1-pentene. Am I correct? See? 3, 3 dimethyl 1-pentene. All right, so let's look at the next one. All right, so the next one, we're looking at the longest chain again. So we draw, and we, of course, start with the one with the double bond because we want to get the lowest number. 1, 2, 3, 4, 5. So the longest chain is 5. If I went the other way, it's going to be 4. All right, so let's continue. So I know where is my double bond. It's on the same one, so I'm going to call this one 1-pentene. Nice. So let's look, and we have some branches here now. Where are these branches? What do we call them? So they are methyl branches. What number carbon are they on? 1, 2, 3. So they are on 3. So I'm going to call this one here 3,3-dimethyl 1-pentene. And I can be like, whoa, sir, but that doesn't look the same. But you see what I've been telling you. All right? By applying your concept of naming your compounds, you can confirm whether or not your isomers are isomers. All right? You can confirm them by doing that. So that's one of the things that I advise all students. Confirm whether or not when you're drawing your isomers, name them as you go about. You draw your first one, name it. Go to the second one, name it. Apply your concept. Keep doing it. Eventually it becomes very easy, and you might even become better than me or better than a lot of individuals who are in these areas. Even better than your teacher. All right? And that's what we seek for you to be, better than us. All right? All right, so it's the same compound. All right? Let's look at the next one. All right? Again, longest chain. Start by having the carbon with the carbon with the double bond having the lowest number. So I'm going to start at this carbon because I'm going to keep it at the lowest number. If I start here, it's going to be at a higher number. So I'm going to start 1, 2, 3, 4, 5, 6. So there's 6. That's my longest chain. Where's the double bond? 1, 2. So I'm going to call this 2-hexene. So 1, 2, 3, 4, 5, 6. That's why I call it hexene. Longest chain is hexene. All right. Then we have our groups, methyl groups again. All right. And there are 2. So I'm going to call them dimethyl groups. Where they are located? 4 and 5. So 4, 5, dimethyl, 2-hexene. Okay. And that's it. All right. So this is going to be the end of it for today. All right. So I'd like to thank you for joining us again for another eLearn session with chemistry. I hope this session was very helpful to you and that you're going to apply this as you go to do your exams, even for students who might be in 4th form and otherwise or 3rd form and seeking to do chemistry, that this session would have been helpful to you. All right, so I look forward to seeing you again on another chemistry session as we continue on this part of organic chemistry. All right, so kudos out to the Division of Education, Innovation and Energy, and we like to thank them for this program, and stay tuned. And as I always say, keep sharp.